Hello students, welcome to today's session. So today we will be discussing one important compound of transition elements, that is we call it as silver nitrate, AgNO3. So this AgNO3 is quite important if you are preparing for NEET examination or JEE mains or advanced, because in many ways this compound is very important, which generally people are not very clear with. So I am placing this video in this regard. So silver nitrate, if I talk of its physical properties, it's a crystalline solid which is highly soluble in water and melts at a temperature around 212 degrees centigrade. It is photosensitive, it easily get decomposed, so that is why it is to be stored in colored bottles and brown color bottles mainly, and it is corrosive to the skin. It gives you a burning sensation if accidentally it falls on your skin. And it is commonly said as lunar caustic. Now this is very important. Why is it called as lunar caustic? Simply because of the fact that just like alkali when fall onto the skin, it gives a burning sensation. This also gives you a burning sensation. So it is corrosive in nature. And as regard to the lunar part, if you say it like that, because silver nitrate easily creates a black spot when falls onto the skin, because it has the property of oxidizing organic substances, and that thereby itself get reduced to silver. So it creates a black spot because of the metallic silver. So that is why it is called as lunar in that sense, just like moon luna. But the point here is you should not do it at your place, that you just put silver nitrate onto your skin and feel it like this, that you would get a metallic silver on the skin. That is not advisable. And as regard to the photosensitivity, as I said, why is it is a very popular question, why is it to be stored under colored bottles? Simply because of the fact that in the presence of sunlight it goes to metallic silver, leaving out these two gases. So this is quite easy. Now the point here is, when you talk of any compound of transition metal like KMnO4, K2Cr, there are number of. So one important thing which you always have to keep it in mind, that when you talk of silver nitrate or any compound, you have to do two things. One, how is it being prepared, and second, what are the probable chemical reactions it can bring about. So as regard to the preparation, if I talk of metallic silver, just would you take pure metallic silver, treat it with HNO3. So this reaction in itself is a quite important and very it leads to the formation of silver nitrate along with NO plus water. And second probable reaction which you can get here is silver treated with HNO3 gives you AgNO3 plus NO2 gas along with water. Now here the point is, which way the reaction would go would depend upon the type of nitric acid you have taken. If the nitric acid is dilute, then you happen to go, so see here, from the redox point of view, it is quite important. It goes from +5 to +2. So there is a gain of 3 electrons, and that 3 electrons must have been given by this silver, because silver has gone to silver 1 positive. And to do the balancing, now I could do a simple thing, that this silver lost 3 electrons, 3 moles of silver lost 3 electrons, and one of the nitrogen happens to go from +5 to +5, another to +5 to +2. So here I shall be requiring 4 moles of it, because only 1 mole of nitrogen +5 goes to +2. So here comes the 3, and it almost got balanced. So this is quite important. Generally we will say NO gas is being released, but if the concentration of nitric acid is a bit more concentrated, of the order of 70-80%, and this is around 20%, then it would go from +5 to +4. So there is a loss of 1 electron, gain of 1 electron. So this must have lost 1 electron. This silver has lost 1 electron. So here the balancing can simply be done like this, AgNO3, and almost it got balanced. Yes, it got balanced. Now the point here is, out of the context I am telling you that when the concentration of nitric acid is low, it tends to behave like a stronger oxidizing agent, in the sense it will take nitrogen to a lower oxidation state, and when it is more concentrated, it tends to take nitrogen from +5 to +4 only, and thereby losing out this NO2 gas. So here the question is, they may ask you that silver when treated with nitric acid would give which gas it can give, depending upon if the concentration is defined of the nitric acid, you categorically would say. If the concentration is not defined, then you either would get NO or NO2 gas. Okay, so coming on to the next, and this silver should be pure. And as a matter of fact, here I just would cover that MacArthur forest process is a process where you happen to do the leaching of impure silver, if you, or gold. Silver is being treated with sodium cyanide along with oxygen along with water to make a water soluble complex of this type, NaAgCN twice, along with the loss of NaOH. So if I just would hurriedly do the balancing, this is 4, this is 4, and here you would get 4 and 4. So this particular reaction is quite a important one. That impure silver is being treated with sodium cyanide, and this silver now happens, the pure form of silver happens to go into the complex as this water soluble complex, and then it is to be leached with zinc. Now this complex, as you know, this complex is then treated with zinc. Zinc happens to go into the coordination sphere, and here I should be taking 2 moles of it, NaZnCN4 along with the, so this is the pure one which you get. Pure in the sense it got leached, the impurities get removed, and you tend to get quite a almost 97-98% pure silver. Thereafter the purification can be done if you just would want to make it very pure. So then electrolytic refining can be used for this particular purification. So this silver then can be used to for this particular reaction to generate silver nitrate. Okay, fair enough. Now coming on to the chemical reaction parts. So and one more thing, I always would advise you to see this particular 2 reactions from redox point of view. That is very important, that in this particular reaction who is oxidizing agent and reducing agent. That particular question can be asked in both of these 2 questions. Would they, first you have to identify, are these 2 reactions redox? If yes, which is oxidizing and which is reducing, and then you have to mark it from the point of view of N factor. Now coming on to the chemical reaction part, if I talk of chemical reactions, what type of reactions? From chemical reaction point of view, one thing is very important for silver nitrate. It's a very good precipitating reagent that we have already done in the salt analysis as well. If you would just see my videos on salt analysis, this, and particularly for the identification of anions or the basic radicals, we definitely have discussed in very much of detail that especially in the acid radicals, that when you have to identify anions, this act as a very good precipitating reagent. So from that point of view, it is quite important. Just see here, I almost have written most of the anions available in our syllabi, and all of these anions got precipitated with silver nitrate. So let me do, and here for some you have to remember some color. So from this point of view, this particular slide is very important. So silver phosphate you would get silver phosphate, silver sulfate, silver chromate. So all of this, silver cyanate, thiocyanate, silver sulfide, then I may go for AgCl, AgBr, AgI, silver thiosulfate, silver carbonate, silver sulfite, then silver oxalate, silver chromate. All of these are important. Silver acetate. So this should be written like this, silver acetate. All of these got precipitated. Silver nitrite, here you have no precipitation. This shows the fact that silver fluoride is water soluble. It is water soluble. It is not going to get precipitated here. Now the point here is, which you always have to remember, is from the point of view of the color. So there are some colors which you always have to remember. This is yellow, this is white, this is red. This red color is because of the chromate ion, and this also dichromate is also red, and it is reddish brown. If I particularly write reddish brown, so it is reddish brown. And most of the other salts you would find are, except for this is black and this is white. This almost are, rather I should write, this is white, this is off white or light yellow, and this is yellow, and all of these are white. All of these are white. Now from here there are few things which you have to keep it in mind, because silver nitrate test is very important for precipitating these anions. As a matter of fact, here you have to remember that if I talk of these four salts are insoluble in acid, insoluble in, if you dissolve most of these anions, these salts of silver are soluble in acid. These four, Ag2S, AgCl, AgBr, AgI, are insoluble in acid. And as a matter of fact, Ag2S and AgI, these are insoluble in ammonia as well. Insoluble in ammonia. This also is very important. You always keep it in mind. Whereas when you talk of these three halides, chloride, bromide, iodide, these chloride, bromide, iodide are insoluble in acid but soluble in hypo, that is sodium thiosulfate. They are soluble in KCN. They are soluble in not soluble in exactly in ammonia. Only AgCl is soluble in ammonia. This is soluble in ammonia. So this I am going to mark in the next slide as well. So from that point of view, it is quite important. Another thing, when this particular salt, silver thiosulfate, is heated, it happens to give you, if it is being heated, it happens to give you black precipitate of this. This is going to give you black precipitate of this, and this black precipitate first would convert, this is white, this would convert into black. And if excess of thiosulfate is added, if excess of hypo is added, then it may also become water soluble in the form of this water soluble complex, just like this, which I am showing it to you now, 3 negative. So this is also to be remembered here. So I am saying that you have to remember these color. Along with it, whatever important informations you are getting here, you should do it along with. Let me repeat what I just have explained to you. These three salts are insoluble in acid, whereas Ag2S and AgI are insoluble in ammonia. In ammonia, only AgCl dissolves, AgBr partially dissolves, AgI totally not dissolves. Whereas AgCl, AgBr, AgI, these three now, if I talk of, they are soluble in hypo, KCN, and partially in ammonia. In ammonia, the solubility of AgI would be the poor one, AgCl would dissolve more. And lastly, what I spoke about is that silver thiosulfate on heating gives you black precipitate, which can further get solubilized in this form. As regard to this two, if you simply would heat these two, now this again is a quite an important one. Here you would get carbon dioxide would go out, silver oxide and carbon dioxide. But when you treat silver sulfite is heated, it would give you silver and SO3 would go out. So this is a redox reaction taking place, and this is non-redox. So from that point of view, it is always has to be remembered. And as regard to this, fluoride would not be precipitated in this. So this particular slide is quite important, and I just would advise you to go through 2-3 times from this particular slide. You may get some question out of it. Now coming on to the other reactions which you would find of silver nitrate, because if you treat silver nitrate with copper or zinc having, if I write their SRP, silver's SRP is greater than that of copper and zinc. So these are better reducing agents. And this silver would act as a oxidizing agent in a displacement reaction. So here you would get copper nitrate along with silver get precipitated, and here you would be requiring 2 moles. Similarly, zinc nitrate, and here you would get, so this is from the point of view of that here it is acting as an oxidizing agent. This reaction is quite important, and this is the utmost very important. Silver nitrate treated with phosphine gas from the P block. From the P block, phosphine is in our syllabus, and phosphine when treated with silver nitrate, what product do we get here? So here it is very important to tell you that you would get silver along with nitric acid along with phosphorus acid. So if I would balance it out, it is quite important. Silver nitrate when treated with phosphine, it's a beautiful redox reaction which you should always remember. You would be requiring 3 moles of water, and here you would be requiring 6. So 6 silver nitrate is being generated along with phosphorus acid, and 6 nitrate ion are still there. So I shall be requiring 6 nitric acid, and I think it got balanced also. Yes, 6 and 9. Yes. Now from here what I just have picked up is that silver goes from +1 to 0. So it have taken 1 electron. So, and phosphorus is in -3 and it happens to go to +3. So here it has lost 6 electron. So that means if it is losing 6 electrons, so there must be somebody who would take 6 electrons. So that is why I took a tip from here. I just have used 6 moles of silver nitrate. So thereafter you can do the balancing. So this is quite important. I just would mark it very important that phosphine when passed through silver nitrate, you happen to get, sorry, this I have written here wrong, metallic silver. Now it is correct. Metallic silver along with H3PO3 along with nitric acid. So this is quite important. Now coming on to the 1-2-3 reaction. If you have ever read this 1-2-3 reaction, 1-2-3 reaction in the sense that you might be knowing Tollin's reagent. Tollin's reagent is a mixture of ammonical silver nitrate. Ammonical silver nitrate. Silver nitrate when dissolved in ammonium hydroxide, we happen to say it is Tollin's reagent. Basically, why I have written 1-2-3, it is a tip to remember. You treat Tollin's reagent to any aldehyde. So you take 1 mole of this and treat it with silver nitrate. In the silver nitrate, silver is present in +1 oxidation state. So it is 2. And since ammonium hydroxide is also there, so it is alkaline. So it is 3. So that is why I refer to it as 1-2-3. Tollin's reagent test is 1-2-3 test, where aldehyde got changed into silver salt of carboxylic acid and silver got precipitated along with the loss of 2 moles of water. So that is why I said it as 1-2-3 reaction, and this also is referred to as silver mirror test. Silver, if you could remember, silver mirror test from the organic standpoint of view. So from that angle it is quite important to remember. Now coming on to the fact that what effect of heating. Effect of heating, generally for any nitrate salt, when you heat at a low temperature, they tend to produce a particular metal nitrite, just like in this case silver nitrite, along with evolution of oxygen gas. Since its melting point is I should write around, if you just would heat around 212 degrees, so it happens to convert into metal nitrite. Most of the nitrate salt when heated gives you nitrite along with oxygen, but there are few metal nitrate which when heated to a very high temperature, they further get decomposed into silver, NO2 and oxygen. So this gives you then metallic silver and these two oxygen, and this would appear as a black spot. So this also you always have to remember. Now the point is, I almost have discussed everything around silver nitrate. The two things which I say it once again is, one, the point is that it is a very good precipitating reagent, and second, the reaction of silver nitrate with phosphine, that is very important. Now you need to do at your place, just make a flowchart of this nature. Here you write all those precipitating anions, carbonate, oxalate, and thiosulfate, whatever we have discussed. And here we have wrote silver plus HNO3 is the best method of preparation of HNO3, where depending on the concentration of these two, you can either lose NO2 or NO gas. Then we talked about the effect of heating. We talked about the reaction with copper. We talked about 1 to 3 reaction, that is ammonical silver nitrate. And then we have talked about the reaction with phosphine, and all those reactions you should write it here. So on one side you wrote the reactions, on the other side you have wrote the all the precipitating thing. And in the precipitating thing, which of these compounds get decomposed or dissolved into acid, ammonia, or sodium cyanide, or potassium cyanide, that thing you can also add it. And here you can write its physical properties. What are the physical? It is lunar caustic, crystalline solid, soluble in water, melting point this much, sensitive to heat, corrosive to skin, things like that. So I almost have done all the things about the silver nitrate. Let us do few questions based on it. So first single choice question can be of this type, that in this you are supposed to tell the n factor of HNO3. In this reaction, here they are categorically writing that you are producing NO. So here simple thing, we just have balanced it few minutes back, that here nitrogen goes from +5 to +2. That means it has gained 3 electrons, and somebody has to lose 3 electrons. That is this silver would lose 3 electrons because it goes from 0 to +1. Now to balance this out, what we need here is 4, and consequently you would get this as a final balanced reaction. Now in this balanced reaction, what you are able to see, 4 moles of HNO3 has lost how many electrons? It has lost 3 electrons. 3 electrons are lost by 4 moles of HNO3. If you just would see, now this is very, very important question, in fact, where you could see that 1 of the mole of HNO3 actually is converting to NO positive. Other 3 moles are just merely acting as a source of nitrate ion. They are not taking part in the reduction. So 4 moles of HNO3 lost 3 moles of electrons, 3 moles of electrons. So 1 mole of HNO3 would lose how many electrons? So it would be 3 by 4. So anything, n factor is what? N factor is number of electrons lost or gained by per mole of oxidizing or reducing agent. So here it is acting as an oxidizing agent, and this is acting as a reducing agent. So here the answer would be 3 by 4. So the answer to this question would be A option, 3 by 4. And as a matter of fact, you could also do it with the reciprocal of stoichiometric coefficient also, because the stoichiometric coefficient, if you would see, if I would write the n factor of this, the n factor of this is 1, n factor of this is 3 by 4. And now if you write the n factor of first one divided by n factor of the second one, that is the HNO3, if you would reciprocate that, n factor 1 upon 3 by 4, so you happen to get 4 by 3. 4 by 3 is the stoichiometric coefficient. So that point of view, it is also quite important to have a view onto it. Coming on to the next problem, here again single choice, but asked from the organic standpoint of view. So glycol is being treated with silver nitrate and ammonium hydroxide. So indirectly they have given this as to be Tollin's reagent. So what is the role being played by Tollin's reagent? Tollin's reagent would convert aldehyde into corresponding salt of carboxylic acid, and then it is to be treated with H positive, and finally NOH and AgNO3. So what options do you get out of this? So we then would treat it with H positive. It would give you oxalic acid, and oxalic acid is treated with NaOH. So it would give you sodium oxalate. Sodium oxalate is being put into AgNO3. It would give you silver oxalate. So the answer to this question had been silver oxalate. That is B option. So this is white precipitate. This is what is being asked by this particular problem. Now coming on to the next question. Next question belongs to more than one choice question, more than IIT Advanced type of a question. 5 anions are given in an aqueous solution and it is being treated with AgNO3 followed by addition of dilute HNO3. So as I said number of times earlier also that all these anions got precipitated. All of these got precipitated on addition of AgNO3. But in HCl or in any mineral acid, only AgBr, AgCl, by the way I am writing AgCl, AgBr, AgI and Ag2S, these would not dissolve in acid. These would remain as residue. So these would not dissolve, make it a point, in a acidic medium. So we are almost through the answer, because all of these get precipitated as silver salts. Silver phosphate, silver carbonate and silver oxalate in the mineral acid would dissolve again and would come into the filtrate. So filtrate has, it is more than one choice answer. Filtrate has oxalate ions only. This is a wrong statement. Residue has silver sulfide and silver bromide. This seems like a correct one. Filtrate has 3 anions. Yes, filtrate would have 3 anions. And anions in the filtrate may get precipitated on. Beautiful statement written here. Because all of these when get precipitated in the filtrate, the solution is still the acidic one. When you start adding ammonium hydroxide into it, it becomes basic and at some stage it becomes neutral. Because as soon as HNO3 and ammonium hydroxide start reacting, the solution would turn to be less acidic and comes near to the neutrality. So as soon as the solution becomes neutral, all these anions which were there in the filtrate again would get precipitated if you add little bit of silver nitrate more into it. So it get precipitated. So this seems also to be the correct statement. So the answer to this question can be B, C, D. Here only thing which you always have to remember, halides of silver, leaving aside silver fluoride and silver sulfide, these are insoluble in acidic medium. Coming on to the next problem. Which gas is produced when silver is heated with nitric acid? This we have already stated in length at the start of today's session, that it can be NO or NO2 depending upon the type of nitric acid taken, dilute or concentrated. Okay, moving on to the next. Which among the following precipitate will not dissolve in HCl as well as not in ammonia? So it is a straightforward factual question which you always have to remember. Silver iodide and silver sulfide would not dissolve in HCl, but AgCl, AgBr and AgI, if I talk of, and Ag sulfide, silver sulfide, these are insoluble in acid, and these two are insoluble in ammonia as well. Insoluble in, I wrote or stated this 2-3 times, and this is soluble in ammonia. This is soluble in ammonia, and this, for this we generally say it is partially soluble. So they would not ask this question, AgBr, would it be soluble or not? But AgCl is definitely soluble in ammonia as this water soluble complex. Okay, so this you always have to remember. Lastly, during the leaching of impure silver using sodium cyanide oxygen followed by addition of zinc in MacArthur process, oxygen is used as an. So during the reaction we wrote 4 silver sodium cyanide, 8 sodium cyanide and oxygen and 2 water. This happened to turn to give you sodium water soluble complex of this type. So where along with 4 moles of NaOH. First you have to see, is it a redox reaction? Yes, 0 to +1 it is going. So it is undergoing this particular thing. If I would write, this is undergoing oxidation. So 4 silver means it has lost 4 electrons. So somebody has gained that 4 electrons. So here this is 0, this is -2. So these two oxygen atom went from 0 to -2. So the N factor here would be 4, because 1 mole of oxygen on gaining 4 moles of electron changes to 2 O2 negative. So what I am saying is that if you give 4 electrons to it, 1 mole of this, when take 4 moles of electron, this will change into O2 2 negative. So that is the point. So here oxygen is acting as an oxidizing agent, and as a matter of fact, always remember that wherever oxygen is given as one of the reactant and is part of a redox reaction, it primarily be used as an oxidizing agent because it always would want to go to O2 negative. Although oxygen do have +1 oxidation state or plus half oxidation state, but it rarely would be act as a reducing agent. It primarily be acting as an oxidizing agent. So this always, you always have to keep it in mind. So I almost have done all the problems. So the point here is that I just would suggest you, while making or preparing silver nitrate, do make this sort of flow chart and put it onto your table. So this particular compound is quite a important one. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.